This section examines starting. The starting system consists of the battery, cables, starter motor, flywheel ring gear, and the ignition switch. During starting, two actions occur. The pinion of the starter motor engages with the flywheel ring gear, and the starter motor then operates to crank the engine. The starter motor is an electric motor mounted on the engine block and operated from the battery. It's designed to have high turning effort at low speeds. The starter cables are the thickest on the vehicle, as a high current must be delivered to the starter motor to turn the crankshaft from rest and keep it turning until the engine fires and runs on its own.
The purpose of a battery load test is to see if the battery can deliver adequate cranking current and maintain a sufficient voltage reserve to power the ignition system. Check it out.
A battery load test can be performed with the battery in or out of the car using a volt-amp tester with a carbon pile. Before beginning, check the battery's open circuit voltage to make sure that it's at least 75% charged. If open circuit voltage is less than 12.4 volts, the battery should be recharged to prevent inaccurate test results. After removing the cables to load test a side terminal battery, install the special side terminal adapters. If your shop doesn't have these, then use a pair of standard thread 3/8" nuts and bolts. With the bolts lightly bottomed, run the nuts up to the base of the bolts and then snug them against the battery terminal using a wrench. Now connect the tester cables and then place the inductive current probe around the tester's negative cable. Make sure that the arrow on the probe is pointing toward the battery so that the ammeter displays a positive reading. With the unit on and the ammeter zeroed, rotate the carbon pile knob until the ammeter registers 1/2 of the battery's CCA rating, which in this case is about 255 amps. Maintain this level of current draw for 15 seconds while observing battery voltage. At a test temperature of 70 degrees Fahrenheit or higher, the battery should maintain a minimum terminal voltage of 9.6 throughout the 15-second test. To accurately determine battery condition at temperatures below 70 degrees, refer to a battery voltage correction chart.
Although carbon pile load testers have been used for years to determine the condition of a vehicle's battery, handheld battery testers like this one are rapidly becoming the tool of choice.
Unlike a carbon pile load tester, digital testers can accurately check batteries in a low state of charge, as well as automatically compensate for battery temperature. These units take the guesswork out of diagnosis by displaying the battery's open circuit voltage, available cold cranking amps, and overall condition.
If starter draws below normal and the engine cranks slowly, it means that there is high resistance in the starting circuit. So take a look at how the power and grounds in this circuit should be checked.
Begin by cleaning the battery terminals and cable connections. This will eliminate any voltage drop in this area. Next, connect the positive lead of a voltmeter to the battery's positive cable and attach the negative lead to the motor terminal on the starter. With the ignition system disabled, crank the engine while observing the voltmeter. This test measures the voltage drop in the starter's power circuit, which should not exceed 0.6 of a volt. This breaks down to a maximum of 0.2 of a volt for the starter solenoid contacts and 0.4 of a volt for the battery cable. To check the solenoid contacts, leave the negative voltmeter lead in place and move the positive lead to the starter's battery terminal. Now crank the engine and note the voltage. If the reading exceeds 0.2 of a volt, the solenoid should be replaced. To check the positive cable, move the negative voltmeter lead to the battery terminal on the starter and connect the opposite lead to the positive cable connector at the battery. Now crank the engine while observing the meter. If the reading exceeds 0.4 of a volt and the cable connection at the starter is okay, the positive battery cable will need to be replaced. To check the starter's ground circuit, connect the negative lead of the voltmeter to the negative cable at the battery and attach the positive lead to the starter housing. If the reading had exceeded 0.4 of a volt here, the high resistance could be the result of loose starter mounting bolts, a poor cable connection at the engine, or a bad negative cable. If the voltage drop across the power and ground circuits is acceptable, then a replacement starter will be needed to correct the low draw, slow crank condition. Before replacing the starter on a vehicle with a slow crank condition accompanied by high current draw, check for incorrect ignition timing, heavy combustion chamber deposits, high viscosity oil, or a tight engine.
When an engine cranks slower than normal, it doesn't necessarily mean that the battery is bad. In many cases, this condition can be caused by the battery cables, the starter motor, or even the engine itself. In order to help isolate the problem area, a starter draw test should be performed.
Begin by connecting the cables from the volt-amp tester to the battery, and then turn the equipment on. Next, with the arrow pointing away from the battery, place the amp probe around the positive battery cable. Now disable the ignition system using the appropriate method. Make sure that the tester is positioned so that you can view the display from the driver's seat. Now crank the engine for several seconds while noting the current draw. Typically, engines larger than 5 liters will produce a reading between 225 and 250 amps, while the draw from smaller displacement engines, like this V6, will be under 200.